hierarchy, TPH, table per type, TPT, table per concrete class, TPC, table per concrete class, TPC. These are the three options what we have discussed up in the previous class about the things now. How to use these, we just been demonstrated up there. And next, I given an outline of the relationships to you. We have three different types of relationships what we discussed, like what is it, 1 to 0 or 1. What happens here? One entity in the parent will have 0 or 1 entities in the child. 0 or 1 entities. Okay, minimum 0, maximum 1. That's all. Cannot be more than 1. That is called as 1 to 0 or 1 relationship. Second one, many to many. What is many to many? Array, one entity means multiple records in the parent can have multiple associated records in the child now. Are you getting me? I given an example. One customer can purchase multiple products, and at the same time, one product can be purchased by multiple customers now. So that's what we call as a many to many relationship. That's what we call as a many to many relationship. And the other one is 1 to many or many to 1. We already know this because our department and employee exactly belongs to 1 to many or many to 1 relationship one. Okay, so let's try to understand about all the three. Let's start with 1 to 0 or 1. We'll start with 1 to 0 or 1. Okay, fine. Let me create a new project. Our last one is CF4. Okay, I'm creating CF5 now. CF5. MVC. Create. Well, now install NT framework tools. NT framework. Fine. Installed NT framework. Next, what I just wanted to do is I want to define my domain classes. I just require to define my domain classes. Yeah, I want to define the two domain classes what I explained in the last class here. One is player and one is spouse. Okay, add a class. What is the name? Player. Now, let me define the attributes for a player. Three simple things here, as I said you in the last class. Player ID, name, and the sport he plays. Okay, so player ID, name, and the sport, what the player is going to play now. So these are the three attributes what I just want. Same way, now I want to write my second model. What is the second one? Spouse. Spouse also has only three columns. What are the three? Again, player ID, name and profession. Player ID, name and profession. Okay, na? Player ID, name and profession. Guys, listen. I want to set up the database generators of here also. Got it? The database generated as off here also. Here also I'm setting the database generated as off. Next. I want this player ID. I want this player ID to be both primary key as well as foreign key also. I want the player ID to be a primary key as well as a foreign key. Both I want. Okay. I want to define that it is a key column as well as it is a foreign key column also. Both the two things. Okay. How do you say it's a key column? We use an attribute called key. It's to tell it's a key. How do you say foreign key column? We use an attribute called as a foreign key. Yes or not? Okay. Namespace not imported. We use foreign key. Foreign key. But do you remember when you're using a foreign key, I said you one thing. Here, you're required to specify the navigation property name now. I have given you two options to you. One, you can use the foreign key on the top of the property and specify the navigation property name, or the reverse. Write it on the top of the navigation property and specify the name of the key property now. Anyway, so here what should I write? Navigation property name now. Correct or not? So here I should write the navigation property name now. Okay, I'll write the navigation property, and the navigation property is not still defined. The navigation property is not still defined. I did not still define the navigation property here. Okay. Now see guys, you want relationships now. What relationship? What relationship? 1 to 0 or 1. How do you define these relationships? Actually, all your relationships are defined based on these navigation properties only. I repeat, all these relationships are defined based on the navigation properties only. So the navigation properties are important for us to define the relations now. Suppose in one table you define a scalar, and one table you define a collection. In one table you define a scalar and one table collection. It's a one-to-many relationship. We've done it already in the case of department and employee. In department, we have a collection of employees. In employee, we have a scalar of department. Okay, now? In both classes, if the property is of type collection, if the property is type collection, first one also collection only, second one also collection only, then it is many to many. Got it? And in both cases, if it is scalar, it is 1 to 0 or 1. In both cases, if it is scalar, it is 1 to 0 or 1. So that is how you are going to tell what type of relationship you wanted to do. Now, what type of relationship we have learned about? 1 to means one class we have a scalar and one class we have a collection. But now I'm going to define both the scalar only. Both scalar. First, let us come to player. Public spouse, scalar property. Same way, come to here. Public player. Public player. And now this name should be used here, right? This name should be used. And I said you one thing in the last class, remember, you can use multiple properties at a time now. Multiple attributes can be applied at a time. Like this, key, foreign key. Both at a time you are using. Got my point? Okay, like this, we can just set up the appropriate things, foreign key, and we're just using up the things here. So now your relationship is 1 to 0 or 1. 1 to 0 or 1. Are you clear about this? Yes or not? You know this, I don't require to tell you. And this one I said you in the last class. This is both the primary key as well as foreign key also. Primary key for this table and foreign key to the player table. Foreign key to the player table. As I explained about the relationships. How? Okay. So now we have the relationships. All the relationships are defined based on the properties. In both classes, if it is scalar, it is 1 to 0 or 1. In both classes, if it is a collection, it is a many to many. In one class, it is a scalar, and one class, it is a collection. It is 1 to many. It is going to be a 1 to many relationship now. So this is how exactly we define 1 to 1 or 1 to many or many to many relationships. And what we are seeing right now is 1 to 1 relationship in this case now. So in both cases, I defined a scalar one. Now what next case? What the next step? Context class. I want to name it as family DB context. Family DB context. Colon DB context. Oh, I did not import the namespace. System dot data dot entity DB context. Are you clear? So I'm just using the family DB context. What next? Public base of constr. Are you getting me? Base of constr. I'm just defining your base of constr. What next? Database always. Family DB context. Next, public. What's it? DB set player players. Public DB set spouse spouses. Okay. Now, what next? Connection string. We need to define the connection string in the config file now. Connection strings. Add name is equals to family DB. System dot data dot SQL client. So just using up all the three things. Okay, fine. What next? Controller family controller. Next, using dot models. Family DB context. Now come to the index action, and I just wanted to insert some records into the table. Which table? First, I want to insert the records into the player table. And as per, yeah, I'm just trying to insert some few records into this table, no, player table. ID, name, and the sport. ID, name, and the sport. So in this two now, when I want to insert the player table, I can insert only for Sachin Tendulkar and Mahendra Singh Dhoni. And Rishabh Pant is still bachelor. So I cannot enter a record for him now. So a corresponding entry will not be available for him. So see here, spouse table. What is the player ID? 101. And 101 matches to the 101 here. The primary key as well as foreign key now. And here, you're just going to save the name here and the profession. And the profession of the appropriate spouse. Okay. Well, now once you inserted your particular things now, okay, let me complete the process. Add them, save changes, and here I'm calling DC dot players, DC dot players, and I'm trying to get the players data back again. Fine, guys. Right click, add a view. Okay, I will have choose the list here. Okay, we'll choose a list, guys. Right click, add view, choose a list model class. We did not build it. Thank you, guys. We not build it. Build. Right click, add a view, list player, context, add. Yeah. Actually, it is bringing up three things here: spouse, name, sport, and this one. Okay, let me arrange them properly first. What I want first is player ID. What I want first is player ID, name and sport, and spouse name, and the spouse profession. Okay, now, and same here also. Dot player ID, spouse dot spouse profession. Yeah, all the edit options and everything you have. Now run. The main thing what you require to observe is not here, guys. Go to the database and you're required to look at the tables in the database. You're required to look at the tables under the database. Okay, let it create the database and generate the view. Sing. Copy paste error. It's a copy paste error. Actually, now we'll get another error. I hope the tables are created of. When rendering, we got the error here. Tables are created of. Now again, the primary key violation error will come off now, I think. Okay. So I can just see now player ID, name, sport, spouse name, profession. Same way, player ID, there is no spouse name and spouse profession here. And for 103, again, we have the spouse name and the spouse profession values available. Yeah. And actually, what I said here, you must go to database and verify actually. Databases, family DB. Why is it taking this much time? Okay. So guys, observe where is the table and columns? It is a primary key column. Can I insert one more record into the table with the same player ID? Not possible. You can't insert one more record into the table with the same player ID. Yes or not? Exactly when you come to the spouse table and see the columns, here also your player ID is a primary key column now. So it's not possible to insert a duplicate record into this column also. You can't insert a duplicate record into this column also now. Yes or not? See now, so you cannot have multiple player IDs, means repeated, duplicate player IDs cannot be allowed. Understood? So this is both primary key as well as foreign key. And now it is a 1-2, 0 or a 1 relationship. You try to insert one more record into the spouse table, but compulsory this record should match with the player ID in the parent table now. If you try to insert a duplicate, primary key will not allow. So multiple records are not allowed. Don't insert, no issue. That's what zero or one record, more than one not allowed. Hope it is clear, all of you. Yes or not? So this is what we just call as 1 to 0 or 1 relationship. 1 to 0 or 1 relationship. Okay. Now the second option, yeah, this one. First player table, primary key is there. Spouse table, primary key, foreign key, both are present. We have a primary key as well as a foreign key present on the spouse table there. Okay, now what next? The next one is many to many relationship. Array many to many relationship, I already said you. One entry in one table will have multiple entries in the other, and the other also will have multiple entries in the first now. And I given you an example for this in the last class. Customer and product. One customer can purchase multiple products, and one product can be sold to multiple customers. That's a many to many relationship. And while defining this one, remember guys, while defining this one, I said you, relationships are not maintained directly through the tables. The relationship comes through a junction table. Yesterday I explained you very clearly about the concept. The relationship comes through a junction table. So first what will have? One table will have all its data. Second table will also, customer table will have customer's data. Product table will have product data. Now the sale is completed. Once the sale is completed, then the data comes into the junction table. What comes in junction table? The values that are associated with both the two tables will come into the junction table now. Are you getting me? That is how it is going to maintain your many to many relationship for us. Okay. And guys, in the previous example, remember, from both ends, from player end and from spouse end, it's a scalar property, scalar navigation property you define. Correct? See now, one player can have one spouse. One spouse can have one player. It is a scalar. Okay, now same way, like this, if at all you are just going to define a complex in both the two places now, it's a many to many now. This first table also should have a complex, second table also should have a complex. Let me show you. So it's 6. Installing NT framework. Next, my first class is product class, product, and my second class is customers. Okay. So product and customer are the two things what I just defined. Now come to the product. In the product, I want to define the attributes for a product. Just two simple attributes, man. Product ID, product name. And database generated option, none. Same like this, when you come to customer, for customer also, I want some few attributes. Just to make it simple, now also they can only two properties, customer ID, customer name. Product ID, product name, customer ID, customer name. Okay now? And you want a many to many relationship between these two tables, correct? Huh? So let's go to the product and see. One product can be purchased by multiple customers. So public I collection. Okay, I collection. What is the name you just want to give? Customers. What is the name? Customers. Oh, sorry. I collection of customers. Gets it. Namespace not imported. That's it. Same I come to customer, public, I collection of product, products. Gets it. See guys, in both the places we define a complex navigation property only. In both the cases, we define complex navigation property only. So earlier, see, this is a third scenario. Remember, first earlier, one scalar and complex. Scalar and complex. Morning, scalar. Now, complex. Now it is a complex and complex now. Okay. Fine, I got it. What next? I named it as company DB, as store DB. Store DB context using system.data.entity DB context. Okay. Now public base of Conestia. Public DB set products. Public DB set customers. Database dot set initializer new drop create database always. Store DB context. Okay now? Well, now let us add a controller. Oh, connections thing is missing. Yeah. Help. Connection strings. Add. Store DB. Database is equals to store DB. Yes. Wait, I'll show you. Well, now controller We'll name it as a store controller. Okay. Well, now I want to insert some few records into the appropriate tables. I created 3 customers, ID name. I created 3 products, product ID, product name. Customer ID, customer name, product ID, product name. Yes, I said you remember we insert data into products table first, afterwards customer table. And the data in the junction table will not come now. The data in the junction table will come only when the sale is performed, not now. Are you clear? So, sir, you'll ask me doubt. Where is the junction table, sir? I'll show you. I'll show you the junction table also to you. Just a minute. Let me finish it. We'll see that. DC dot save changes. DC dot save changes. Right click, add view. I'm just creating a blank view. I'm creating a blank view now. Okay. So let me run this. When I run this, automatically the 2 tables are created now. Product table is created with products data. Customer table is created with customer data. Okay. Now I want the data. I want some database. I want a table called as a junction table, and the junction table should contain the information of both product and customer. Product and customer. Okay. Okay. Index launched. Now go to database, refresh. Fine. You got the third table, see? Product customers. Any name here, it will give some name like a product customers is the third table. So you see, this is a customer table where your customer table has 2 columns. Customer name, primary key column. Same way, come to your products table. Here also have 2 columns. Product name. Now come to product customer. Here also we have two columns. First one, product ID, customer ID now. This product ID is a primary key as well as foreign key, and is again a primary key on foreign. It's a composite primary key, guys. It's a composite and a combination. It is going to create you this one. Okay, but product ID will refer to product table is product ID. Customer ID refers to customer table, customer ID. This is the junction table. Sir, any data in the table? No, I don't have any data in the table. That's what I said to you in the last class. I explained you this only. The site, first the company stored all the products data in the products table. Now they're giving me an offer. What is the offer? Come and register in our sites. When the site is launched on first, we'll give you 25% discount on all the products now. And the customers who started registering in the site. Now your data is stored in the customer table. So both these two things. Now the sale should be processed. You're required to design the sale process now. Now when the sale is going to happen, at that point of time, the data comes into the junction table. It comes into the junction table. Until then, the data will not be coming into the junction table. But I want to show you how the tables are going to be created. That is my intention. Hope you guys are clear. Okay. So this is our way how it is just going to create. Basically, we call this as a database diagram. In SQL Server, you have that option here. Tables on the database, you have diagrams also. You can create them. Tomorrow, when you're working with more number of tables in the database, relationships and all, we don't understand. We don't understand now which table is linked with what and all. So we basically call it a DFD, data flow diagram. You can just create it like this. Simple. See, we have an option here. Right click, new database diagram. It'll ask you what tables you want to represent here. Customer, product, customer, add, product, and product, customer, and close. You can see the things. You can drag and put them in the way you want. Is that clear? This is called as a database diagram. You can see that it represents. So tomorrow, when you are working with multiple tables and relationships, at the time, it will give you a clear picture. Array, what table is connected with what table is connected with what table. You can easily see in the diagram. Okay. Yes, I use the database diagram only to represent you the things. Is the picture clear? This is all how many to many relationships work. Third one, I hope I don't require to give you an example for one-to-many relationship. Department and employee table. Are you clear? Department and employee table. Already we saw one more example also. Categories, products. Categories is a parent and products is a child. Yes or not? One category can have multiple products, but one product can have only one category. One product can have only one category, but one category can have multiple products. Are you clear? We also saw that. We already saw that. I'm creating it, guys. Actually, we already created it. I want to show something new here. That's it. Otherwise, we already done that. No need to create this. But I want to show you something new. So again, I'm creating you the department and employee ones. Are you clear or not? Okay, I'm not giving any explanation because we already done this earlier. So straight away, I will implement it. I want to teach you a new thing. Just I want to tell you a new concept. For that, I'm only explaining this one. Just a minute. What happened to my system? And we need to understand one more thing. In all these databases, we are seeing one table called migration history, right? Now, also, we just got that in the list. We did not select it. I'll tell you, we'll talk on that in detail in our next sessions. We'll talk. But first, let me show you example on one to many. Nothing here. We did not look at department employee. I want to show you that that's all. What we will be category? Department employee, we are looking in DB first. We did not work in code first. In code first, I'm showing you that's all. Okay. So create a new project. Seven. Same. Install anti framework. Next, two models. One is department. Department. Second one. Employee. Now, a department requires the attributes of a department. An employee requires the attributes of an employee. And the department, there should be a complex navigation property. And in the employee, there should be a scalar navigation property. Correct now? ID, name, location. Okay now? And what I taught you, no need. We can do it in the same line. Simplification. Now, when you come here, what do you have? Public I collection. I collection of employees. Get set. Generic. Okay. Now go to employee. And here define the attributes for an employee now. Okay. And this is my foreign key, guys. This is my, and guys, watch it. How am I inserting the values in it? Say, how am I making it the foreign key? First, let me define the navigation property. Public department, get set. Alright, last two examples to define a foreign key. What did I do? On the top of the column, I specified the navigation property name. Now I'm showing in the reverse order. As I said you. Alright, next example, I'll show you in the reverse. See how to write foreign key and tell you is another way of writing the foreign key. And first option, foreign key department. You can write like this. This is what I shown you in the previous example now. This is another way of writing. And see now, it's a scalar. It's a one to many relationship or a many to one relationship. Yeah, I just defined up the required classes now. What next? Context. New class. I'll name it as a company DB. Company DB. Using system dot data dot entity DB context public. Oh, I forgot context. No need. Just let's follow the conventions. That's all. No need of writing as a context here, but just following the conventions. That's it. Company DB context colon base of on STR public DB set department departments public DB set employees database dot set initializer new drop create database always company DB context. The reason for showing you multiple examples and writing the code multiple times is if the time waits for me also. But I see repeatedly you've done for 7 examples till now. So you must get the flow into your brain now. So what is the first step? Install the entity framework. Second step, the domain classes. In this, first you're required to define the model classes. And while defining the model classes, now you remember what you want. Eliminate redundancy. Then you're required to use the yesterday's concept. Inheritance strategies. Establish relationships. Today we are talking what type of relationship you want. One to one or many to many or many to one. Based on that, you define the domain classes now. And the next context class. When you come to the context class, this context class, you're required to just set the connection string here and you're required to specify the initializer, what initializer you want. And you know about the DB sets. I want to make you clear with the flow one by one what we are doing. Understood? What next? Next step, connection string. Go to web.config. Connection strings. Add. Name is equals to constr. Connection string is equals to data sources server. Database is company DB. User ID SC. Password 123. SQL client. Done. Now come here, define a controller. I think I defined a controller called as an employee controller. Company controller. Company controller. What else? Okay. Now come here in the index table, in the index, try to insert some records. Guys, have a look. You learned about all the things. First, department, adding them. Next, employee, adding them. Save changes. Now see the return view. Include the department. Include the department data. So get me both employee data as well as department data. So what do you do? Right click, add a view, and we see 5 view. Build, add view, list, model is employee, context is company DB context, add. May not be adding all the things. Once it creates, you adding the rest will be easy now. So that's what I'm doing. So what is missing? First, employee ID. Name, job, salary. Name, job, salary. Next, department ID, department name. Next, location. Come below and repeat. Dot EID. Location. EID. Okay, run. That company DBR. No, we don't have company DB. It will create you. So all this relationship maintenance is done with what? How do you define the relationships here? With the help of navigation property. The navigation properties will decide you what type of relationship is going to be established. It's a one-to-one, many-to-many, one-to-many, and all this is decided by the navigation properties. What you have? Okay. Got the data from both the two tables, and you can go to your database, refresh, company DB, go to tables. You should see the tables. Departments and employees. Well, actually, we are writing of static data, guys, but actual process is not that now. What I showed in the first example, create a controller for department and create the views for adding, updating, deleting, and all. Right or not? Same way, create a controller for employee and you write all the views. The first example I shown you that only. For a category, I created you separate controller views. For a product, I created you separate controller views. And I am asking you to do all these things. Because again, without wasting the time showing each and everything to you, I am just only showing you, array, a CRUD and database created, see watch. That's what I'm showing you. But I want you to complete all the things to in this now. Understood? Separate controller and separate view for each and everything. Now, listen. When you're working with the databases, guys, when you're working with databases, some tables should be having default data. Some tables should be having default data. What is it? Some tables will be having default data. For example, you have some 10 tables in your database here. 10 tables are going to be created by NT framework, but some tables may require some default information in that. Some default information in that. Actually, right now, in a company, I tell you a scenario. We are working on a project here. We're just working on a project. It's a very complex project, actually. So mainly, the main thing is a database here. What is it? Our client is like United States Golf Association, USGA, United States Golf Association, the client. They will be selling tickets for the golf. They will be selling tickets for the golf tournaments. When the golf tournaments are conducted, they'll be selling the tickets now. Okay. So throughout US, all golf clubs are under the control of this USGA. Under the control of the USGA on the top. And they will be selling tickets for the various clubs throughout the country now. It's a golf is a very big sport in US. Golf is a very big sport in the US. So they'll be selling the tickets for number of people. And when they sell the tickets, see, there are cinema theaters. Cinema theaters are not selling the tickets directly. We can purchase, but still book my show. A third party. Not only in book my show, you can purchase your tickets in Paytm also. Multiple sellers are there who are selling the tickets. Correct? USGA is our central authority, and all golf clubs are under the control of USGA. Understood? They conduct the tournaments, and when the tournaments are conducted, they sell the tickets now. But these tickets are sold by different providers. Like Book My Show not only sells the tickets for the movies here, they'll sell you tickets for concerts, any special events, for everything they'll sell the tickets. So like that, there are different providers in the country who sells the tickets. So right now, all these means whoever sells the tickets, all the information should come and fall under a database table now. So earlier, they designed an architecture like this. What is it? All these providers are connected to one central database, and the database is present in Amazon Web Server, AWS. The data is present in Amazon, AWS. Okay. And the database name is Redshift. So throughout the country, all the providers who sells the ticket, the data comes and falls in the tables now. There are different tables like this. Ticketing orders that will contain the order details. Ticketing payments that will contain the payment details. Like this, different tables are there, and each table will be storing you different data. Initially, they designed an architecture like this. Afterwards, they will pick the data from there using Excel sheets. They are just to aggregate them and find out what is it, how many tickets are sold, how much money is paid through credit card, how much money is paid through like cash payment, how money came for a check payment. Like this, they used to do like segregation like this. From past 4 or 5 years, they're doing it like this only. But it became complicated for them to aggregate and all the things. So now they asked us to build an application now. They asked us to build an application. What that application is? The application is a website. The website should have a date picker on the top. If I select a date, whatever tickets are sold on that particular date, it has to show me all the data for different tournaments now. They're not the same tournament, different tournaments. So tournament 1, what tickets are sold, how much money is collected. Tournament 2, how much money is collected. And below, they want a detailed agree how much money is collected through credit card, how much money is collected through cash, how much money came through checks. Like this, they just want to build us an application. Here, UI is not at all a matter at all. Here, UI is very simple. Application, our MVC application, we designed an MVC application only. It's very simple. MVC core, we built an MVC core. The latest MVC core 8, we have just built the application. That is very simple, yeah. All the challenge, all the challenge is database only, yeah. To collect the data from different tables, aggregate the data, and present it according to client's requirement. UI, we did not spend any time at all. All the time we spent is in query writing only. Writing these queries only, we spend a lot of time. Okay. And here, the biggest challenge for us is the data is present in Amazon Redshift. And the client, actually, we need to connect from .NET application to Amazon Redshift. When you want to connect from .NET application to Amazon Redshift, see, we are using SQL Server Provider now. SQL Server Provider is given free by Microsoft. But if I want to connect with Amazon Redshift, if at all I want to connect with Amazon Redshift now, I need to purchase a third-party provider. We need to purchase the third-party providers. SQL client is free, guys. Microsoft gives you. But if at all you want to go for any third party, you have to purchase them manually now. Very costly. It is very, very costly. And the client is not ready to invest that much money for that. Client is not ready to invest that much money for that because that's annual licensing. Again, after 1 year, this license expires, it won't work. Are you getting me? So this is the challenge. So we used in Azure, we just used the concept called as ADF, Azure Data Factory. So what is Azure Data Factory means? It is basically a transformation service. It will connect to one database and pulls the data and puts in another database. So it's an Azure service, Microsoft Azure service. So we configured this Azure Data Factory every day. At one scheduled time, this ADF connects to Amazon Redshift and pulls the previous day's data from various tables and stores them in the Azure SQL Server database. Did you understand me or not? Actually, according to our time, evening 5:30 p.m. it runs. According to our time, evening 5:30 p.m. Evening 5:30 p.m. means their time is 7 a.m. in the morning. For them, it is 7 a.m. in the morning. So what it will tell you? It will tell you the previous day's data. Today morning 7 a.m. I cannot get today's data. Na? So what it gets is previous day's data. So evening 5:30 p.m. we triggered it. So what will this do? This will connect to Amazon's Redshift. It will pull all the data from this and it will store this in the SQL Server. Now our MVC application, what is it? Our MVC application directly connects to SQL Server and pulls the data. So we don't require to purchase a third-party provider again now. So who is doing that? The ADF is pulling off all the data and storing in SQL Server. If I want to connect with SQL Server, free now. System.data.sql client is free. It's inbuilt. But if I want to use a Redshift provider, I need to purchase annual licensing policy again. Without all this headache, this is how we designed the architecture. So when you are fetching the data from these tables here, there is a payment table, ticket payments. The ticket payment table contains the information of the payments. For every payment, there will be a status. What status? Is the payment successful or failure? Is the ticket booked or not? Two different things will be there. What's it? Payment status, success, and again the ticket status, booked. These status are same every time. Yeah, status won't change day by day now. Different status are there. What is it? Approved status, confirmed status, failed status. Like this are different status. The status will be same always. Am I right or not? The status will be same always. So we identified some few status, what the client has said us. We identified and we have populated a table with all the status values. We populated one table with all the status values. Okay. Now in the ticketing payments, for every ticket, the status is stored. What is the payment status? Payment status 1 means success. Payment status 2, processing. Payment status 3, failed. Okay, payment status 4, denied. Like this, you have different status values. See now, when I'm pulling the data from my ticketing table, can I pick all the records, sir? I cannot pick all the records, sir. I can pick only the records which are confirmed booking. Are you getting me or not? Confirmed booking. So where the information is present, status table. That is a separate table, status table it is. Are you getting my point here? Now status table data is fixed here. 4 or 5 different status are there. That is a fixed data. Always the data should be present in the appropriate tables now. Are you clear? So for every application here, we'll be having some tables which have fixed data. The data won't be changing again now. Are you getting me or not? So exactly tomorrow in Code First, when you're working with Code First, suppose you are creating all these 10, 20 tables, and in that you have a payment status table. The payment status table requires a default data now. What data do you require? ID and the description. 1, success. 2, failure. 3, processing. 4, processed. Like this. And it's a fixed data. This data won't change. Okay, how do we deal with these type of scenarios? We call this as seed data. What do you call? Seed data. And this data should be populated into the tables the first time the database is created and the tables are created. Did you catch my point or not? The first day the database is created and tables are created, these tables should be populated now. Array, for that I am not going to create any UI for the user to enter the values. There are fixed values that are defined by the company. You also won't do that. Understood or not? So that's what. So minimum multiple tables will have some default data, guys. These default data cannot change now. That is fixed. How are we going to manage these type of things? And in NT framework, we call this as seed data. What we call? Seed data. So how do we deal with seed data? How are we going to have the seed data? For example, in our department employee, I want department table have default data. 4 departments in the organization, fixed. Are you getting me or not? My company has only 4 departments. That is fixed. I'm not going to have any more departments now. So I don't require to create any views or controller for department. That's default. I want only views for employee. Recollect, we created only views for employee. Initially, when we created department table manually, on the day, instead of manual data into the department table, do you remember or not? Now also I want to do now. No views creation for department. That is fixed data. So I want this data should be inserted the first day the table is created. The first day the table is created, I want this record to be inserted. Got it or not? And it should not be duplicated now. It should not be duplicated. How many times it has to go? 1 time. And that is default. First time only it has to happen. So what we call this process as? We call this process as seed data. How do we do seeding now? How do we do that? How do we insert the default data? That's what we are going to learn. Is the concept clear first? Yes or not? What is it? When we are creating tables, some tables require static and fixed data, which will not be manipulated going forward. How we are going to put that default data into the tables? And we call that concept as seed data in our entity framework. Okay now? Yeah, guys, that's what exactly we are going to learn. What is it? Seed data in entity framework. Database initialization process. This is important when we want to provide some default or master data for any tables in the application. For example, in our previous application, if we want to insert default data into department table, then we need to use the concept of seed and insert default data into the table. Okay. To seed data into any table, we need to implement the logic in seed method. Where you need to implement the logic? In any of the three initializer classes. Three initializer classes are there for you now. What are the three? First one, create database. If not exist, drop create database always. Create database if model changes. In that, you have a method called as seed. You're required to write the code inside that method now. Are you getting me? And now when I say that, we'll have a doubt now. Sir, how can I write code in that method? These are predefined classes now. They are predefined classes. So how can I write the method in the class now? I cannot write any code in the class now. Am I right or wrong? So can I write code in that method? No, these are all predefined classes. So there's no chance of writing the code inside of the method now. Are you getting me? Then do one thing. Define a class inheriting from any of those three classes. I defined a class called as myDBInitializer. My class name is myDBInitializer, inheriting from drop create database always. Then automatically my class is also going to be the same as a drop create database always now. If I inherit from create database if not exist, then my class also behaves as a same now. Are you clear? And then override the seed method because the method is virtual. Because the method is virtual, override. Now after that, don't use the old class now. Use what? The new class. Use the new class. For example, what I'm telling you is, listen, let's look at this example code. Go to the DB context. Old initializer you used. Now inside this class, there is a method called as a seed. And I want to write the code inside the method, but not possible. It's a predefined class now. So what do? Create your own class. Create your own class. Inherit from drop create database. So new class is also drop create database now. Use that class here. And write the code in that particular new class by overriding the seed method. By overriding the seed method, we are going to do that. Okay. Just observe the process here. To seed data into any table, we need to implement the logic in seed method of any of the three DB initializer classes. That is, create database if not exist, or drop create database always, or drop create database if model changes. And to do that, we have to define a custom DB initializer class inheriting from any of the three DB initializer classes and then override the seed method. Test this process, add a new class in models folder of our previous project. What is the name I'm given? Company DB initializer is a new class, what I'm defining now. So guys, observe. Let's go to the which class? Sorry, which folder? Models. Right click, add a class. What is the class name we are planning to? Company DB initializer. Yeah, someone said that we can use extension methods. Or you can use extension method when the method is not there. The method is already there. We need to write code inside the method. Understand? See, you remember extension methods? You watch the video of extension method. When you define extension method, when a method is not there, to add a method to the class, we use extension method. But what I'm telling is the method is there, guys. I need to write code inside that method now. So I cannot use extension method now. What I can use is inheritance. When I inherit, that method is automatically entered to the child class. If it is virtual, override. If it is not virtual, hide. Overriding, hiding, anything you can do now. Okay. Well, this class should inherit from any of the three initializer. Which one shall we initialize? Which one shall we use? We'll use this one only. Which one? Drop create database always. Drop create database always. And you are going to specify the context class name now. What is it? Company DB context. Company DB context. Now override this method. Which method? Seed. See, when I say override, you got it, see? Seed. Okay. And here you see you have the context class object here. You have the context class object. See what I'm doing. Let me go to the company controller and all this code. Let me copy from here. Not copy, cut. Cut from here and paste. Alright, this is not DC, the name is context. I'll always change the name as DC there. Alright, data context only now. And then DC dot save changes. Did you understand what I done? I defined a new class inheriting from. So this class is also drop create database always only now. And inside of it, I'm overriding the method and implemented all the logic. Now go to company DB context, remove this, and in the place of this, what will you use? Company DB initializer. Use company DB initializer. So no need to specify the context class name. No need. Why? We did not define it as generic. Na? We defined normal class only. We did not define it generic here. We defined normal. And this is already using context here. So I don't require to do it again. Okay. Now this is the class what I should use in this place now. Okay now. And now when will it'll execute? All these initializers will come into picture when the database is created now. When the database is created and the tables are created, immediately seed method will run and inserts all the default data into the tables. And don't forget, this code runs only one time. When the first time the table is created. Second time again, this code is not going to execute. Is my point clear, all of you? Yes or not? A second time again, this is not going to execute. It will automatically just go for creating only one time. See now, you have some code written in the seed method and you have some code written in the index action method. And this is for inserting data into employee table. Yes or not? Observe this, all of you. Let me come here. The connections is open here. I'll get an error. So manually deleting the database. Let's come back to the application, run. When I call the index action method will insert the data into employee table, correct? But before that, the seed method inserted of my data into department table, man. Before that, only seed method inserted of my data into department table. Now the data is going to be inserted into employee table. I'll show you the difference. See, you are doing the same code in the seed method and this one, but different tables. There department table, here employee table. Otherwise, you are doing the same code and check it out. See, what did you write? Created instances, adding save changes. Come to your controller. Same only, man. Table is different, that's all. Am I right? Okay. So let us see. Yeah, got it. Refresh. Okay, refresh. And now I am just going to see my, which one, guys? Company DB. Company DB. Tables. Departments and employees. Just a minute. Open a query window and just check it out. The data is inserted or not. Select star from departments and select star from employees. Okay, now all of you observe it. Observe this one. Now let me stop my application. One more time, I want to run my index action method. One more time, I want to run my index action method. Okay, now when I run my index action method, again in index action method, you are written inserted 4 records now. These 4 records will be inserted again into employee table. Check it out. But department data is not inserted. That's what I'm trying to show you. Are you clear? So this is a proof to you. What is it? The seed method runs only one time. It won't run again and again now. See, right now, you have 8 records in the table. Sir, primary key violation will not come. Why? I use database generation option. So automatically IDs are generated. 1, 2, 3, 4, again 1, 2, 3, 4 is generated. It's in just a minute here. Just a minute. Wait a second. Delete it. Connections open. It will fail here. Connection open. It will fail. I forgot to check this checkbox. Check the checkbox. Click it. Let me come here. Just a second here. Let me not use this one because this will always drop off the database. Let us use create database if not exists. Are you clear? Create database if not exists. So what is my policy? Create database if not exists. Okay. First time I'm running this. Even in my notes also I used model changes. Anything you can. I first shown you drop create database always. Now I change it to not exist. And in the notes I given you model changes. Yeah, now no model changes are there. So database is not going to be recreated. Yeah, got it. How many? 4 records. Yeah, 4 records. Here 4 records, here 4 records. Let me stop. Let me run the index view again. Now you will have 8 records in employee table, but department will have 4 records. Here auto generation is there now. It will generate 1, 2, 3, 4 again. 5, 6, 7, 8. Same names and all. Just want to show you. Only thing is seeding is not happening for second time. See there? 8 records. But go to your database and verify. Department table is not having duplicate values now. Why? That code doesn't execute for the second time. But see, employee table. Just what I want to preview is seed data will not run for multiple times. Seed data runs only one time. When, sir? When the table is created, the database and the table are created for the first time, then only seed data will execute and inserts the data into the appropriate table. Otherwise, seed data is not going to run again and again for you. Is it clear about seed data now? Yes or not? So compulsory in every application, there will be some tables which requires default data, and all the default data should be inserted in this particular fashion only. Hope I am clear, all of you. Understood or not? Okay, this is about the seeding of the appropriate data. Okay, take a break, guys. We'll meet back after 20-25 minutes. Okay, take a break.